The internet has been very off. Okay. Operations with rational and irrational numbers. So we need to talk about what a rational and irrational number is. A rational number can be written in the form of a fraction where A and B are integers. Integers are whole numbers that are negative and positive, and also the number 0, okay? So if I can write it as a fraction, like 1/2, 7/9, something like that, then it is going to be a rational number, okay? If I have a decimal going on, come on, pen. Why is it not right? There we go. A rational number. Okay, so we have fractions, like I said, like 1/2. We could do even decimals, as long as they don't like repeat and like don't have like a weird pattern. So if I had like 1.5, that's a rational number. I could even have 1.33 repeating. That would be okay. That is rational. I could even have a square root of a perfect square. So like square root of 16. That's fine because that simplifies to an integer of 4. So these are all examples of different rational numbers that we could come across. And there could be negatives in there. Negatives don't really change anything. Okay. Numbers that can't be written in that form, these are called irrational numbers. Okay, so numbers like this, there's going to be a decimal that does not repeat, like there's no pattern going on. One of the famous numbers that does that is pi. It's 3.141592653. It just keeps going. There's no repeating numbers, therefore it's irrational. Other examples could be square roots of numbers that don't simplify. So square root of 16 is nice because it's an integer, but if I have like square root of 2, or let's say like negative square root of 5, those numbers cannot be simplified to be an integer, okay? Isaiah, yes, I am recording. All right, so these are examples of rational and irrational numbers. So we're just going to, that's all we're going to focus on today is what, I'm going to try to add them, multiply them, see what kind of number I get out of it, and we're going to see some kind of pattern that goes with that. All right. All right, determine whether or not these examples are rational or irrational. So remember, if I can simplify it to a whole number, or if I can simplify it to a nice pretty fraction, a decimal that does not go on forever with a weird pattern, those are all rational numbers. So the first one, square root of 9. Well, I can actually simplify that to just be the number 3. So since I get the number 3, that is an integer. So I'm going to be able, I know my connection is bad, guys. I'm going to try them. I will upload a video, I promise. Square root of 8 cannot be simplified. So because the square root of 8 cannot be simplified to be a nice pretty number, that is going to be an irrational number. Pi, that was one of our examples. It's a decimal that goes on forever with no pattern, therefore that's an irrational number. 22/7, well, those are two integers written as a fraction. 22 and 7 are good, so that's going to be a rational example. 9.48, notice that bar above it means repeating, so there's a pattern, 48, 48, 48, 48, so that will be a rational number. 33/2, again, that's a fraction with two integers. 2.23606 ... that means it's going to continue. I don't have a bar on top, so there's no pattern that they're showing me, so that's going to be an irrational number. And then finally, -25. Technically, I could put it over 1 and make it a fraction. Those are two integers, so that is going to be a rational number. Okay. So questions on what is or is not a rational number? Good. I don't see anyone's hand being raised. Remember, that's always a feature. You can raise your hand, which I don't see going. Okay. I'm going to continue. All right, so here are some rules that they want me to prove. So it says, given two rational numbers, A and B, prove that the sum is also a rational number. So they're claiming that if I do a rational number plus another rational number, that I'm always going to get another rational number, okay? Sum means adding. So it's saying it's always going to be rational. Well, let's prove it. Let's think of a rational number. Someone give me a rational number in the chat. Give me a number. All right, 1/2 and 25, good. So if I did 1/2 plus 25, and -25 would work also. That's the same thing as subtracting. If I did 1/2 plus 25, I would get, what, 25 and 1/2, right? Those are all integers, that's gonna work. Good job. I could even do two different fractions. What if I did like 1/3 plus 1/3? That gives me 2/3. That's still a nice pretty fraction, so it's gonna work out. This one is gonna be the same thing as 51/2, by the way. All right, good. So that is proof that whenever I put two rationals together, we always get another rational out of it, okay? What's gonna happen if I multiply them? Do you think we'll still get a rational number? Well, this must be to prove that that will happen. Given two rational numbers, A and B, what can be said about the product? Product means multiply. So it wants to prove rational times rational is going to give me another rational, okay? So again, give me some examples. What do you, give me a rational number. Let's see if we can do it. Ooh, 0.77, good. Give me another one. Nine, great. Okay, so 0.77 times 9, y'all make me use my brain. Let's see here, 0.77 times 9, that is going to give me 6.93, which is a rational number. It is a decimal. It does not go on forever without a pattern. That is good, awesome. So rational plus rational will always give me a rational. Rational times rational will always give me another rational, all right? Good job. Now let's explore what happens if I put an irrational number in the mix, okay? So this is saying rational number A and an irrational number B. So we're doing rational and irrational. Prove the sum, so we're gonna add them again. They claim it's gonna be an irrational number, okay? So give me a rational number. 8, okay? How about an irrational number? Those are kind of harder to type. How about square root of 2? Is that okay? If I do 8 plus the square root of 2, there's really nothing I can do. I can't add that because they're not like terms. That's as low as it gets, and I still have an irrational in my answer. Therefore, I do have an irrational number as our answer. So when I add and there's an irrational number involved, I get an irrational number out of it. Okay. Let's see if it happens when we multiply. So what's going to happen, and it says non-zero on purpose, because if I multiply by 0, I always get a 0 out of it. So we're not going to include that in any of these numbers. Okay. If I give a rational number A and an irrational number B, so we have a rational and an irrational, what can be said about the product? So that says multiply. Okay. Well, let's think about it. Give me another rational number. 29, good. Rational number of 29. I'm going to use pi this time. What if I did 29 times pi? Ooh, square root 13. Here we go. Let's do that one instead. Okay. Good. If I multiply 29 times the square root of 13, that simplifies to 29 square root 13. Nothing else I can do. There's a square root in my answer that cannot be simplified to a nice pretty whole number. So it will always result in an irrational number. Okay. So if I add or multiply and one of them is an irrational number, my result is going to be an irrational number. Okay, so let's fill in this table with what we just said. All right, so we said rational plus rational will always be irrational, okay? We said rational times rational, same thing. It's always going to be a rational number. Then we just discovered that if we add or multiply one irrational number, it's always going to give me, whoop, come on computer. There we go. Another irrational number for both of these. Okay. What we haven't explored yet is what's going to happen if I have two irrational numbers. Okay. If you're looking at your notes, this is not in your notes, but you might want to write it somewhere on back of your paper, or if you're writing on your own piece of paper, I would definitely write down this table because it's going to help you. Okay. Especially with your homework, your quiz review, and your quiz. If I am adding two irrationals, let's think of two irrationals. What if I did, oh gosh, what if I did square root, what if I did square root of 3 plus, we'll say square root 3. Well, that just gives me 2 square root 3, right? So that's irrational. But what if I did this? What if I added a negative? What if I did square root of 3 plus negative square root 3? That's the same thing as saying square root of 3 minus square root of 3, which is just going to give me a 0. So when it comes to adding, looks like I could get either one as an answer. So there is a special case where I could get 0 as a result. And if I do get that special case of 0 being a result, then my answer is irrational. So when I add two irrationals together, we can get one or the other. So this one's going to be sometimes irrational or sometimes rational. This is an example of how I get an irrational number. This is an example of how I get a rational number. All right, let's see if anything special happens if I multiply them. Come on, pen. Hold on. Oh my goodness. Okay. There we go. There. All right. Now let's multiply. So if I have an irrational times an irrational, okay, let's use pi. If I do pi times pi, okay, what happens? Well, we get pi squared, right? That is an irrational number. Okay. Is there ever a time where I can multiply two irrationals to get a rational out of it? Okay, the answer is yes. If I multiply a square root to itself, like let's do square root of 3, well, because I used it before. If I do square root of 3 times square root of 3, well, that's the same thing because they're like terms. I can say that's the same thing as square root of 9. Square root of 9 is 3. So this is a special example of how I can multiply two irrational numbers and get a rational number out of it. So this is also going to be sometimes I or R. So sometimes it could sometimes be irrational, or it could sometimes be rational. Okay, so this right here, this table is key. This is going to help you with everything that we are going to do with rational and irrational numbers. So take a picture of it, write it down, do whatever you got to do. This is very, very important. So I'm even going to pause for a second to let you guys write this down. Everything is being recorded, yes. So yeah, you can also go back to this later if you need to. All right, I'm looking to see if any hands are raised. And I do not see any. Yes, everything I record, I put on YouTube, so it will be there. And then the quiz review that I do after, I will record that and put that up also. All right, we have a hand. Sean, did you have a question? Oh, okay. That's okay, Sean. Cameron, yes, it should be, well, it'll be posted today at some point. I still have to make the video. I'll record what I do after lunch and I'll post it. So it'll be done before I leave today. I'll send y'all a remind message when it's done. All right, let's do some practice problems. Here we go. Consider the following expression, 2 plus the square root of 3. Okay, well, I'm adding, so I know this is going to be a sum. The number 2 is a rational number. And the square root of 3, okay, square root, I have to make sure I can't simplify it, and I can't, so that's going to be an irrational number. So if I'm adding, looks like I'm adding a rational and an irrational, so what does that give me as a result? It will give me an irrational number. All right, topic 3, Sean, is a lesson today. And then we're going to do a quiz review, and then you're quizzing on Wednesday. And then we're going to do a new lesson afterwards. All right, let's look at number 2. All right, Maria and her 6 best friends are applying to colleges. They find that Bard College accepts 1/3 of its applicants. Maria and her friends write the expression below to represent how many of them would likely be accepted. All right, so we have 7 times 1/3. If you're confused on where that 7 is coming from, it said Maria and her 6 best friends right here. Maria and 6 friends, that's where 7 came from. So together it's 7. All right, we are multiplying this time, so that is a product. So we have a product this time of, all right, well, 7 is a rational number. Because I could write 7 as a fraction, right? I could put it over 1, and 7 and 1 are both integers. I'm multiplying it with another rational number, which is 1/3, 1/3, both integers. So we're doing a rational times another rational, so that's going to be equal to a rational number. Cameron, the answer is yes. Getting a good quiz grade will very much improve your grade overall. All right, we are almost done. I believe we just have these 2 left. All right, let A and B be non-zero rational numbers. Okay, so whenever I see A or B, I know it's a rational number. And C be an irrational number. All right, consider the operations below. So A plus B, well, A and B are both rational numbers, right? So that's the same thing as saying rational plus rational, which we know will give me a rational number. The next one, A minus C. well, A is a rational number, but C is an irrational number. So because there's one irrational in the problem, the whole thing is going to result into an irrational number. All right, my next one is A times B. So that's going to be a rational number times another rational number, which will result in a rational number. You can also plug numbers in if you're not quite sure. You could like make A 1, make B 2, keep it easy. Make C pi, and that's just another way. So those are examples of rational numbers if you want to plug them in, and then you can make C an irrational number, you can use pi. If that helps you also see it. All right, the fourth one down is A divided by B. So that is A and B are both rational, right? So that's a rational divided by an irrational. If I made them actual numbers, I could do 1 divided by 2. That is a rational number. A nice pretty fraction. Our last one is A times B times C. So that is a rational times a rational times an irrational. Okay, well, let's group them together. These first two are going to still be irrational, right? But then when I multiply by that irrational, the whole thing becomes irrational. Okay, and again, if I plugged in the numbers 1 times 2 times pi, that simplifies to just being 2 pi. So it is an irrational number. All right. All right, last piece of our notes. Consider x times y equals z. If z is an irrational number, what can be said about x and y? Okay, so x, I had to multiply x and y together to get z, right? So I multiplied two things together and I got an irrational number. Okay, so what does that tell me? Well, let's go back to that chart. How could I get an irrational number from multiplying? Well, it looks like I can get it if one of them, right? If one of them is irrational right here. I could also get it though, this says sometimes if I multiply 2 of them. So what do we know about it? We know that if I multiply 2 pieces and I got an irrational value out of it, that means at least one variable, so it could be x or y. Oh, come on, pen. X or y is irrational. Okay, so they could both be irrational, that is possible, but one of them definitely has to be. So x or y, or x and y. Okay. There is a worksheet that goes with this topic already on Canvas. It is very quick, so do that during your lunch. Come back after lunch. I can answer questions about the worksheet that goes over these specific things. And then I'm going to go over the quiz review with you guys. So make sure you come back so we can get ready for our quiz. All right. All right. Have a good lunch.